Welcome everyone to the education panel, where we'll be talking about different methods for teaching and learning Scala from a panel of esteemed experts on this subject. I am your humble moderator. My name is Kelly, and I'm going to be asking the questions to start this panel off. But what's going to happen, we'll all introduce ourselves. I have some pre-planned questions that we've come up with, and then we are going to save some time for audience questions at the end. So as we're talking about different topics, if anything inspires you or if you came with a question in mind, please save that for the end and we will have time for questions. So once again, my name is Kelly. My experience with Scala education comes a lot from the organization that I've been involved with, which is Scala Bridge, where we teach Scala to women and underrepresented groups, especially people that might know an existing programming language but don't know Scala yet. And so that's been an interesting experience of teaching Scala to some newcomers, and I'll pass on the mic for introductions down the line.
My name is Heather Miller. I'm the executive director of the Scala Center, and I've taught Scala, or not Scala classes, but I've taught classes that happen to be in Scala, both at EPFL and at Northeastern University in Boston. And I've also run a few Scala Bridges. So I've taught mostly students in university or women and underrepresented groups as a part of the Scala Bridge program.
I'm Martin Redeski, and I taught Scala before it was a thing. Literally, we were like 3 weeks into Scala compiler when we started courses with it, and every week I tried to essentially just do the bare minimum of essentially the functionality I was teaching next week. It was a crazy race. It was like 24-hour days or so. That was the beginning at 2003. Now we've come quite a long way from that.
I'm Marc Lewis. I'm a professor at Trinity University, and I've been teaching intro courses. We do our CS1 and CS2 using Scala. We've been doing that since 2010, and then it bleeds into the higher level classes like web apps and big data.
I'm Ryan Tanner. I'm a software engineer at Twitter, where I also teach 2 courses on the Scala Collections Library.
Hi, I'm Neville Lee. I work at Spotify, working on data and machine learning infra. And we switched from Python to Scala about 5 years ago and using it mainly for data pipelines. And I've onboarded a lot of engineers. We grew from about 20 engineers 2 years ago to like more than 300 people writing Scala data pipelines on a full-time basis.
Hi, my name is Pasha Gurupada. I work at Wire in Berlin. I started to learn Scala in 2013. For some time, I was a part-time Scala, part-time Java developer, and I evangelized more Scala in my old company. I moved to Berlin a year and a bit ago, and now I'm full-time.
Excellent. So that gives you a bit of background on the people up here. The first question is for Heather and Neville. How do you help newcomers understand Scala-isms, whether those folks are new to programming or just new to Scala?
So the way I personally like to do it, and perhaps this comes from me wishing that it was done this way to me, is first to provide examples to people, and then to make sure that someone understands that example, and then say, oh, by the way, that's called this ism. You just learned it, but I didn't scare you with the name first. So I like to do it that way.
And for me, most of the people I work with are like data scientists, data engineers who are used to Python or R programming. And Scala is a really big language, and there's a lot of parts that's like not really required to be able to do like solve business problems. And Scala is also really great for like building DSLs that's very concise, very easy to understand and intuitive, like Spark or Scouting in those cases. And we just teach the core fundamental like functional programming concepts like collections, combinators, and how they relate to data processing. And that's our approach.
Awesome. Ryan, Twitter has a very extensive internal training program for Scala that might be unique to a lot of companies. Can you share what works about that and how other companies could benefit from what Twitter has built?
Sure. So I think one aspect that sets it apart is that we make the cost of onboarding and training people in Scala explicit instead of implicit. We don't try to hide it. And what I mean by that is we have millions upon millions of lines of Scala. We have a huge engineering force, and we hire quite rapidly. And we don't expect people to come in with Scala knowledge. We have to ramp them up on that ourselves. And so we have made that investment explicit. We have an internal training program staffed by full-time instructors. We also recruit engineers to teach their own courses. So on benchmarking, on futures, I teach courses on the collections library. We're also, in my department out in Colorado, we're experimenting with a new onboarding program. It's 30 hours of training courses on Scala and the Twitter stack spread over a new hire's first quarter. So we're hoping that that gets people to what Kate Heddleston has called reliable independence faster. It's an ongoing experiment.
Excellent. And is there anything that other companies could start to adapt based on what Twitter has done? What do you think would be a good first step for others in industry?
I think the first step is getting buy-in from the rest of your engineering organization that teaching is part of their job description.
Awesome. Moving over to the academic side of things, this question is for Heather, Martin, and Marc. You all use Scala in an academic setting. You all have been professors. Can you talk about what it's like to teach students with Scala, especially the difference from students that might already know an existing programming language to some, Marc, you mentioned that you're teaching the very 101 classes using Scala, and how that might differ from your experience teaching in other programming languages or languages that are more commonly seen in universities.
Okay. Well, because we start off in CS1 with Scala, I get to shape a lot of the conversation that way. And in many ways, what I like about Scala, and the reason why we use it, is because we use it across 2 semesters, there really aren't that many programming languages that work well for both the CS1, which scripting languages work really well for that, and also work for large applications. We do a more of an object-oriented approach in our CS2. And because Scala has a scripting environment, I can basically, my CS1 is almost like statically typed Python in some ways. That's how I approach it, with as much functional as I can throw in on it. But it grows very naturally into our second semester class where we are breaking things up. We're doing more of an object-oriented approach for larger projects and telling them how to structure code, not just build logic.
So at EPFL, we start with Scala in second year after currently first year Java. That's actually the MOOC, the Principles of Functional Programming, that by now we also run as a MOOC for the students. So I interact with the students only at the so-called recitation sessions when essentially they solve problems on a whiteboard. So what we do is, so they know Java, and then essentially we sort of throw them at the deep end of the pool, doing pure functional programming. If you have followed the course Principles of Functional Programming, then it's basically Abelson Sussman, that book, and so it's essentially fairly academic, which works well in an academic environment. So we don't really start with combinators for, let's say, collections, which I think would be the right approach, the gentle approach to teach them. But we essentially start with the bare minimum, just functions, producing functions, and then sort of we build up from there. I think it works well. It is a shock for many students first to be sort of thrown in there. The advantage is that they like the challenge, and also they see that it's worth it because essentially they know there are a lot of jobs out there for Scala, so it's not something that essentially they have to do just essentially to please their professor. They know that it's useful for something.
So my experience has been to teach a course that comes after the Principles of Functional Programming course at EPFL, which is a parallelism and distribution kind of course, and I was teaching Spark. And at that time, the students had already been using Scala for a while, so it wasn't much for me to teach them new about Scala. However, maybe what's more interesting is the experience that I had both with Scala Bridge and also at Northeastern University. At Northeastern University, I was teaching a group of mostly seniors, but they had learned Racket, which is a functional programming language, first. And for them, it took one day, one lecture. As this is, you know all these things. Here are higher order functions. Yeah, this is just what they look like in Scala. And oh yeah, there are some types, but no big deal. And in this case, it seems like the concepts transfer very easily if you can just get them to look at a different, it's just the syntax that's a little different, and it's really fast. At least I've learned if somebody has a little bit of experience on the functional side of things. But what I found really exciting about the Scala Bridge experience, earlier today I mentioned it in a talk this morning. Basically, I have lots of different individuals at the Scala Bridge. And there was one occasion where I had a few teenage girls who had never programmed before, and they didn't even have a laptop, they just had iPads. And there were a bunch of JavaScript developers. And what happened was that the JavaScript developers kept on tripping and stumbling on the immutability stuff. And these two girls, they kept raising their hands, all these JavaScript developers saying, I can't do that, I'm just trying to reassign this thing and it's not working. And again, we explained it a few times, to help people understand one by one. And then I think the girls kind of, just said, but they tried to answer somebody's question, be like, well, why is it so hard? You just, you want to transform something and you get a new thing, you just use the new thing. It makes total sense. And they had no experience ever before. So what I found which was pretty cool was that, some of these concepts are quite straightforward to newcomers if they had never learned any other way, which was a really cool takeaway.
Awesome. So this question is for Marc. Do you think that we should be doing more of what you're doing in the 101? And how could, if so, how could the industry influence the use of Scala in academia?
I would love to see a lot more of the CS1, CS2 taught in Scala, and it's not just because I've written the only textbook on that subject. No, I think it actually is a really good fit, and I think if you'd like to have more employees who understand Scala when they come out of college, you need to tell your local colleges this. Okay? The reality is that many academics are at least sensitive to the fact that they want their students to be learning valuable skills. But many of them are all completely out of touch with what the valuable skills are. And in that regard, they would be very willing to hear from you telling them what you think would be good for students to come out with. Tell them, and not just Scala, but one of the big challenges that we've heard, there have been quite a few talks about training people with Scala. The tripping point is the functional aspect. The tripping point is the immutability, because people have been trained to think in one way, and then they have to be retrained to think in another. And getting people to unlearn stuff is often harder than learning it in the first place. You should go tell your local universities, hey, we use Scala, we use functional programming. I'd love it if some of your students came out with that knowledge. I think that would have a big effect as far as growing the community and giving you better employees that you don't have to spend as much time training up.
Excellent. Moving back over to the industry side of things, Maciek, you did some research on how people bridge the gap in resources from complete beginners to some of the resources for experts. What are your recommendations based on that we can use to help bridge that intermediate gap?
So in preparation for this talk, we made a small survey asking questions about what motivates people to learn new programming languages. And in one of the answers, the most popular one was that when people become more confident enough, they start to write their own small projects as part of learning. But the problem is that we have on one side a lot of materials about how to learn simple concepts, and then on the other side we have this very concrete answers to very concrete questions on Stack Overflow. And there's like a shortage of materials in between. So actually that's a question to all of you writing open source projects, but also not open source. If you reach a milestone in your project, then please stop for a moment, think about what was important, what you've done, how you've done what you've done, and write some articles about it, write some, at least part of documentations in simple words that someone can access it, and if they decide to write something similar, then they can simply follow your steps. So for example, what the build tools you used and why, and what were the problems, how you connected them together, what were the libraries, and so on. So apart from the fact that you help people, you can also rethink some important points in your code, and also because most of those small projects are becoming abandoned at some point, then maybe you can simply recruit the authors of them to work for you. So a part of that energy that is going to be wasted will go to your projects instead.
Excellent. So Martin, this question is mostly for you, but it really applies to everyone here. How do you keep material accessible to newcomers when you're so far removed from being new to the language?
Well, that's easy. I'm reminded every year afresh with essentially the freshmen who come in, and if I'm too advanced, then I just see a lot of faces which don't understand anything. So unlike an engineer where you naturally progress with your team from essentially beginner to expert status, as a teacher, you fall back every year and with a new generation of students, so that keeps you well grounded generally.
Excellent. So maybe Ryan or Neville, that you might have a comment on this. How do you bridge that gap with people when you've been programming in Scala for so long?
Sure. So when I picked up the Beginner Scala Collections course at Twitter, it was one course at the time. I then split it into beginners and advanced, and 3 slides in, it dove into variants. So I have now rewritten that. My first exercise is literally check if a collection is empty, because the bulk of my audience is people fresh out of college who are only used to Python or Java, who have never been in a functional environment or an environment that enforces immutability. And so every time I teach this course, I make the exercises simpler and simpler and simpler, to the point where I'm up there trying to play charades, trying to explain what a flat map is. And I've been working in Scala for 8 or 9 years now, and teaching beginners on a regular cadence has really helped me explain to myself these concepts that I know too well to explain off the top of my head.
Excellent. This question's for anyone who wants to take it. What's your approach to introducing category theory concepts like monoids and functors? When do you introduce them, and what motivates you to introduce them, if at all?
I can talk about that. So there are a lot of category theory concepts. Like if you go to Scala conference, some of the conferences you hear things like free monads and tagless final and some other monad transformers. And there are a lot of them, but it really depends on the domain. So in my domain, like data and ML, actually the only 2 concepts that we teach, and it was at the end of the data engineering training, is monoid and semi-group. And then we go through the step by step. Like you start with in-memory collections, filter, map, flat map, reduce. And then we explain how these, typical Scala combinators translates to distributed system concepts like, MapReduce and word count and optimization, like, do map site reduce and lifting functions and stuff. And after that, we, introduce the concepts of associative and commutative operation. And then it just, fits naturally into this context where semi-group and monoids, they're just ways to do word count. So it really depends on the context. I mean, we want to avoid feeding developers or new beginners like concepts that doesn't really apply to their day-to-day job yet.
So we teach in the first 7 weeks. We don't teach any monads or categorical concepts. But we do teach them for expressions and how they map into flat maps and maps and filters. And then week 9 or 10 or so, in the first 7 weeks, we also show them that essentially anything that has a map and flat map can be the target of a for expression, so not just collections. And then we play on that a little bit. We do essentially quick check, so essentially random calculations, and then we do try, and then we introduce monads, and we essentially prove that try is not a monad because 2 of the laws are broken. Don't hold in this, and that's about it. Then the next course is reactive programming. That was Eric Meyer who gave that, one of the fathers of monads, and he started off the course with the thing that, well, let's talk about monads. A good example of a monad is try. I said, Oh my God, we just. But then Eric actually specified that when he thinks about monads, he thinks about the type structure. He doesn't care so much about the laws. That's about as far as it goes in our courses. I think it's important to be inductive in teaching, so go from the concrete to the abstract, and that's why I think category theory is something that essentially would probably be good in its own course, or definitely it's something that comes much, much later than the functional introductions.
Any other thoughts on that one? All right, we can move on. So there's quite the spectrum of Scala styles, from the Java++ to the, Ryan gave me this, the Haskell fan fiction style. How do you guide your students or your team to writing and agreeing on a specific type of Scala?
I'll take that. First of all, I can't take credit for that. I saw it on Twitter. I don't know who actually came up with it. But in my part of Twitter, in my organization, we focus very heavily on what we call synchronous code reviews, which is we do not just open a pull request and send it off for someone to look at. You drag someone over to your computer and sit down and go through the diff together. And that is, in my opinion, one of the absolute best ways to indoctrinate new hires into your style, either having them review the code you're working on or you going over and reviewing it with them in person, face to face. That ensures that you're getting into the meat of what you're actually reviewing, and that's the best place that I've found to explain why they might want to do something differently or why your team has agreed on a certain style.
All right, we can open up the questions to the audience now. We have a microphone right in front of Heather, so if you want to line up behind that, we are fortunately not passing around a mic.
So the question is to all of you, but specifically to you, Martin. Yesterday you said that you don't like the fact that people look at Scala as a better Java or a worse Haskell. But what I lack when I teach newcomers, developers in my team is like Scala the right way. Because, for instance, if you want to combine effects, which is something that happened in the real world, you can use EFF, you can use monad transformers, but right now in the current version of Scala, there isn't, like I would say, a simple way to do that. So it's already getting complicated even when you're trying to show the easy stuff. So like what I'm asking is either something like Scala the right way, because I use sometimes tagless final when it makes sense, sometimes like in a less pure way, we combine things. But there's no like one good way that...
We're working on it, and I'm really glad that you raised that question. So when Scala was invented, it was very much also thought as an answer for essentially to bridge the gap between static and dynamic languages. So it was designed to appeal to Python programmers, Ruby programmers, and I think it was fairly successful in that way. So that way, that means that at the time we didn't really consider expressing a lot of properties in the types. So I think initially the answer in Scala was, well, we don't talk about effects. Effects are implicit in the code. They're essentially, they're there or not there by convention. Now people have essentially progressed quite a lot. They found that actually they want to talk about effects and that there's a real use about effects. And I think you're right, the language natively doesn't really provide a lot of the right abstractions, and I think right now no language really does, because if you want to talk about effects, then essentially all you have is monads and then some way to deal with them, whether with transformers or free monads or things like that. So the next version of Scala, so Scala 3, will have essentially a baby version of algebraic effects, which are much, much nicer for the composition and which essentially hopefully will solve the problems that you have. I say baby versions because essentially those effects are all effects that are not, essentially all effects except control effects. So that means you can say, I declare to do I/O, to do mutation, also to throw exceptions. That one we don't count as a control effect. And all these things can essentially be done in these baby effects, and they will compose really well using implicit function types. The ones that are not covered are things like future, that needs a control effect. But then in a lot of code bases, maybe you only need one of them, namely future, and then you don't need to do monad transformers, because as right now the situation is a single monad is fantastic. We have all the support for that, and once you combine monads, things get hairy.
We're still open to questions from the audience if people want to join.
I've taught a lot of Scala professionally and in other ways. I find that I run into a problem with anyone who doesn't have a Haskell background when I get to higher kinded types. So after higher kinded types, the other things I find are easy to teach. You know, you can teach a functor, you can teach a monad, you can teach all these things once a student understands higher kinded types. So what have you found to be the requisite knowledge to fully understand higher kinds?
Yeah. That indeed, I think that takes some getting used to, and I think we have definitely a lack of accessible tutorials for that. There was one recently which was, I think it was F brackets underscore explained or something like that. That was a really good one, but that's a very recent one. So I think we need more sort of really tutorials for sort of the basics before we go to these other concepts. That's definitely true. I don't really have a clear way to say, well, what we could do there for how to teach it. I don't really have a good answer myself, except for these things.
Any other thoughts?
Yeah, I don't actually think we ever cover that in any of our courses at Twitter. Even our functional programming in Scala course, it's based on the Red Book. I don't know what to say.
Yeah.
Oh, I was just going to say that we don't teach it at EPFL either, to the undergraduates anyway. So I think then actually the people on the stage, I don't think have experience teaching higher kind of types of students.
Yeah.
Not really.
No, we don't get that far, no.
So I think there's a good variety of the types of things that people, especially on the stage and even in the audience, have deemed necessary to teach. And I think that's one of the interesting things about the language of Scala. While all of you rush to the microphone, I can ask another question. Are there any tutorials that you wish existed? You know, we kind of got on this, there aren't a lot of tutorials for higher kind of types. What else is kind of missing out there? What do we need more of?
I think an accessible, well, not accessible, but you know, a type system tutorial. Doesn't have to be higher kind, but I mean, you know, I would hope that higher kinds are in there. But if I want to just understand Scala's type system, there's not like a good thing I can read. I mean, there are lots of different things I could read. There are some examples in this book or some examples in that book, and there are these blog articles, but there's not one self-contained place that I can go to, you know, see what the things in the type system are and what the examples look like, and then, you know, why that's useful for writing programs. I think that's something we're missing.
Any other thoughts on missing tutorials?
When I find something missing, I create it. So.
Thank you. And we are grateful for that. Yes, we have another question.
Yeah, so my organization's got a small group right now of pretty expert Scala developers, and we're looking to spin that out to a lot of our Java developers starting to, you know, contribute to some of these Scala systems. What are some of the high level kind of categories and classes you'd kind of recommend, and kind of what order would you recommend we approach that in to train out a ton of Java developers into more of a Scala base?
So we start with a course we call Scala Essentials, which is, I want to say, 12 hours long, spread over a few days, and it covers the syntax, the basics of Scala. Then we move into futures in the Twitter stack, so Finagle and Finatra, whatever your stack is. But we start with the very basic of, I think sounds similar to Dr. Lewis's course, use it as a scripting language, open up the REPL, play around, get them comfortable with it. We move on from there towards the stack itself, and that's where we can have them actually build something and deploy it off into a real production environment, and they get that hands-on experience as quickly as possible.
What I'm interested in is teaching not Scala. The other departments at the universities, economics department, social sciences, aeronautics, engineering, how much is being done, or what is being done to bring Scala to those students?
Okay, the example that comes to my mind is our business department at Trinity. They do a fair bit of data science and data analytics, and I try to twist arms to get them to move to Scala, but they're very set on Python, and I do think, so some of the reasons for that I consider to be misguided, but some of the reasons are I think very real, and like one of the big ones is you want to look at your data. I think that plotting is an area where right now the Scala ecosystem is somewhat lacking. It's much harder in Scala to pull in some data and just throw it up in a quick plot to see what it looks like. And so there's a certain number of tools that we're lacking to make it harder to branch out into people who are less serious about the programming. And if you're talking about large scale and you want to run things that are distributed across clusters and whatnot, yeah, Scala's there for you. You need a lot of threads. You're going to be using futures and stuff. Do not go to Python. But if what you're doing is a reasonably small data set and you just want to play with it, do some statistical analysis and throw up a plot, right now we don't have the libraries, and that makes it a much harder sell there.
Just totally unrelated, I agree with you, but totally unrelated to that, one thing I just, so I recalled when, again, teaching a Scala Bridge, I noticed that if we give introductions and everybody says why they want to learn Scala, where they come from, everybody gets to know each other at the beginning of these things. And I've noticed at least half of the people that come, they might, again, this is Scala Bridge, so it's women and other underrepresented groups. They might be in business, they might be in biology, and they thought, well, I think programming is probably useful. I mean, they don't necessarily think that maybe they're going to use Scala for this. But then they find out, oh yeah, I work in something related to bioinformatics, and oh, that Spark is written in Scala, okay. And then they maybe stick with it. But I found, just in the context of Scala Bridge, by saying, hey, you don't have to have really any programming experience, we just want to, spend an afternoon learning how to program in this language called Scala, people kind of come out of the woodwork because they think, programming is something I should learn to do because maybe my job or, whatever I'm doing that might not be hardcore back-end development, right? That might be useful. And actually at Scala Days in Berlin, somebody came up to me and they asked, well, why don't local meetup groups and things why don't they do like a Scala Bridge, but like not underrepresented groups Scala Bridge? Yeah. I'm like, first of all, I don't know, I can't control local meetup groups, but one idea, if anybody is interested in sort of just spreading the joy of Scala, you could do this in your local meetup group and say, hey, anybody who wants to come and learn how to program, ideally somebody who comes from maybe other fields and whatnot, say, we'll do this once every few months and come and have, have some pizza and we learn. And I bet you $5 you're going to get a bunch of people who come from different backgrounds, and eventually you might see more like NLP libraries or things that are not hardcore, like the 5 areas that people are jumping on top of to build Scala applications in. I would encourage people to do that if you're interested in organizing something like this in your local group.
There was a Scala study group in San Francisco circa 2013 that has since disbanded, but it followed that model of let's meet up, once every couple of weeks, and maybe we'll follow a curriculum for a while, or maybe people can just bring their questions. I know this is something that a lot of other meetup groups do regularly, especially in San Francisco. Obviously, that's a larger tech scene, but I think there's definitely an opportunity for something like that.
So to overgeneralize a little bit, I find we have sort of two types of students. And one is super eager to learn new languages. They'll come back the next day and tell you about this tutorial they read. And then the other group is sort of, hey, I just want to do the minimum, learn the minimum to do my job. Do you have ideas for motivating or reaching that latter group?
Whenever I have to work with that latter group, it usually, what I try to do, I can't give you like a one-size-fits-all solution. For me, it's been, depending on the class, right, find a different way to motivate them. One way I've motivated them is by trying to show them that their efforts would either be seen by other people, like you have to write a blog article and put it on the internet, and somebody could Google it, right? And then they go, oh, okay, maybe I should, maybe somebody's looking for, I'm a senior, I'm graduating, if there's somebody Googling my name when I'm applying for jobs, I should care about this, and they try really hard all of a sudden. And then the other thing is to kind of, go back to the, examples and sort of what motivates the group of students that you're working with. I would say at EPFL, the students are a little bit more academic and they're fine with kind of like cute little academic theoretical problems. In the US, I found that students, they want to build something that they can see and use, right? And so getting them as quickly to, like I said, it depends on the group. But getting them to, as quickly as possible, to that thing that they really wanted to actually do with the language, and then they have a reason to learn these funny concepts that you're trying to teach them. I found that helps. So I have these kind of two things that I try depending on the group that I'm in.
So in my classes, I try to keep the students hands-on keyboard as much as possible so that they are actively coding. And in my advanced course, I try to leave them with something they can use beyond the course, not just a little throwaway application. So in that course, it's a JMH benchmark suite for the collections library. And I try to make sure that they're seeing how they could use that in their regular work on their team and not just in this little class they're taking at the company.
In my opinion, it's okay to just want to learn, enough to get your job done. In our case, like people want to write data pipelines, and it happens to be in Scala, but they want to write pipelines to solve business problems. And a lot of the APIs libraries are designed so that it requires minimum knowledge of Scala, and you can sort of just, tab completion your way through it, which is okay for like people who just want to do the job. But we also try to motivate users, like if you learn a little bit about how the API is designed, like implicit arguments or the type classes or whatever, that will make your job much easier. You can decipher the error message, and there's always some more advanced power user who can help you out. So that's the way we see it.
So now that more and more of the people coming into the Scala community are coming from dynamically typed environments, one of the things I've occasionally seen when I'm doing training or people in Gitter and stuff like that, one of the things I've seen them stumbling on is the concept of types, because they've never seen a compiler before and they don't really understand it. I'm curious, how early do you introduce the idea of a type, and how do you describe it to people?
Before this question gets answered, I do want to point out that Ely gave an excellent talk earlier called Teaching Scala for the Statically Typed, or Statically Challenged. So there's a longer form answer to this that I will point you to that will be recorded soon.
Day number 1. Okay, and in fact, this is why I like Scala for CS1 as opposed to Python. I care about types. I think types are very important. I love the fact that the Scala REPL, when you type in the number 5 and hit enter, not only gives you back that it's a 5, it tells you, and 5's an int. Okay? And I utilize that in my class. I want my students to understand types. That is right front and center from the very beginning.
Mark, this is mainly a question for you. It's a follow-up to your comment earlier that you work a lot with data scientists who work in Python and they prefer Python. What do you think is kind of like the killer motivating feature for them to move to a different language like Scala? If you just say it's type safe, most of them don't know what type safety is, so that's not a killer feature for them. If you say, ooh, now we have visualization, they'll say, great, we've had it for years. In order to beat an incumbent, in order to displace an incumbent, we need features that they feel they can't do their job properly without it. So what do you think in your experience would be some of those things?
Well,
I think, sorry, Mark, did I say Martin? Yeah, no, but any of you can answer. Any of you can answer, but I think Mark was the one who mentioned Python.
So actually the talk right before this, we're talking about historically speed would have been one of the big ones, but apparently, for example, in Spark, the Arrow project is giving Python a competitive run there. As opposed to just saying that you have types and that you have type safety, you can motivate that in a different way, because what type safety gives us is early detection of errors. Okay? The fact, especially when you're processing large data sets, if this is going to run for a while, it's really nice to know that you screwed it up, immediately, as opposed to waiting 24 hours and then finding out that you screwed it up, because inevitably what it's telling you is one of your 5 screw ups, and you can spend the next week finding them if you get your feedback once a day on long runs. So I think that would be one of our major motivating stories for static typing. It's the early information, it's the higher quality information. It really helps us to solve our problems effectively. And that's something that the dynamic languages can't do for you.
I want to just add a little bit on top of that. For us, most of the big data ecosystem is in JVM, so like Scala just makes a lot more sense. We have like single data flow jobs that process like hundreds of terabytes of data, which is simply impossible in Python. And the other thing is the composability of a lot of, we use this Twitter library called algbird heavily, which is basically a library of semi-groups, and that's using type class to automatically derive behavior, like type classes for summing various complex data structures in parallel. And as long as you express your type correctly, and the library will just perform the computation without the user ever having to write any code. So that gives a lot of the agility and the correctness guarantee to the data pipelines.
Thanks.
I think we have time for one more question.
Hi. So we've been hiring developers for the past 6 months, 8 months, and we do a pre-screening on the phone, so it's 5-10 minutes. And they always ask, what technologies do you use? And we use Scala, Play, Akka, and most of them are from Java, even PHP, none of them are Scala, and they ask, why Scala and not Java? You can say, because it's less code, it's easier, but in 5 minutes, how could you answer that question to a developer that makes more sense that just it's easier and less code?
That's probably for the application.
Thank you.
That's a good question. I don't know how our recruiters answer it. My answer would be that Scala gives us abstractions that, especially back when Twitter was moving off of Ruby, which I wasn't there for, so I can't speak to it back then, but when they were moving off of Ruby, Java didn't have a lot of the abstractions it's now gained, partly because, as Martin said in his keynote, Scala started shipping them on the JVM. Java didn't have those abstractions, Scala did, and Scala offered the power to express ideas in ways that made it easier to scale a service the size of Twitter. Even just something like Algebird that Neville just mentioned, which comes out of Scalding, lets you very succinctly express business problems in a way that you can then scale across thousands and thousands of machines in a way that Java is still kind of glomming on at this point.
So at Wire we use Scala for an Android application. It's a very reactive, very chaotic environment where many things happen at once. And Scala gives us possibility to still keep track of all of that, because of the many features in Scala are very well like thought of. They can interact with each other. So we can still have a very precise code in only like 1/3 of Java code, where everyone can really see these abstractions and keep it in their head, how the graphic user interface interacts with the storage, interacts with the backend, and so on. So with Java, with the amount of the things that we would have to write, would mean that we couldn't like have space for new things, and we would waste much more time on just keeping track of what we are doing.
Martin, any final thoughts on why Scala?
1 sentence, 2 sentences.
2 seconds. Okay.
2 sentences.
2 sentences. I think it's still a language that is much more direct, that expresses things much more directly in your domain than what Java can do. So true, Java has closures now. This is definitely progress. But I mean, the mere fact that there are expressions and statements and you can't do anything in expression sort of holds you back, and you sort of, it's almost impossible to be truly functional in a language that is statement-oriented. And that's just one thing, but there are many, many others. So I think it's just a sort of no-fuss, get-to-the-point language. That's like how I think about Scala. And I guess the developers, that once they learn it for a while, they tend to like it. So it's temporary, I hope.
Excellent. Thank you all for joining us tonight. Give a big round of applause for our panel. We will stick around as long as we can if you have any further questions. Thank you.